Hey everyone, my name is Christopher Brennan and my partner's name is Nathan Phillip. Today we will be talking about our project plan for a quantum resistance checker.
Alright, so for our agenda today, we'll be looking at problem statements, project goals, recent work done by others, proposed solutions, step-by-step strategy, and key milestones. Problem statement. So, quantum computers, instead of normal computers which uses binary bits with zeros and ones, they use qubits, which has 0, 1, a linear combination of both, also known as superposition. They have immense computational power and could lead us to a lot of scientific breakthroughs. But with all that processing power, what happens to modern day encryption? Will they be compromised? A lot of symmetric encryptions are safe, but asymmetric encryptions like RSA and ECC could be in trouble, since they rely on the difficulty of finding factors to be secure. Quantum computing was inspired by Schur's algorithm, which is designed to find those factors really quick. RSA is widely used in day-to-day communications and VPNs, so there is cause for concern. And as we're getting closer to quantum computing being more accessible, people and organizations might be interested in looking at the risk analysis for this topic. They might want to see how different applications would respond to quantum computing and get a risk assessment. That is primarily what we are focusing on with our project. Relevant and recent work by others. So, we had to do a lot of research for our topic. We had to make sure we weren't just reinventing the wheel. We were able to find a lot of information. Cryptera and the National Academic Press published these amazing reports with a lot of information that helped us. They both detailed how many qubits it would take to break different bit encryptions, but they also go very in depth into the topic as a whole. But once we looked, we couldn't really find anything similar to what we were setting out to do. Project goals and outcomes. Our primary goal is to make a quantum risk analysis tool, which we are calling the Quantum Resistance Checker. Our goal is to create this sort of website tool that people can use to search up an application and see how resistant that is to quantum computing. We're hoping our capstone project will help create a centralized location where everyone can access detailed reports on how different applications fare against quantum computing, what encryptions they use, how they store their keys, and our goal is to create a risk analysis tool that will help fill the gap between application security now and application security against quantum computers. This solution can be used to see which application could be viable against the coming of the quantum computers.
As Nathan stated, our goal is to create a risk analysis tool. This tool would give a report about a selected application's encryption. These reports would show the number of qubits it would take a quantum computer to break an application's encryption, as well as other useful information, thus showing how viable a selected application could be against the development of quantum computers. Our plan is for this tool to be in the form of a website where we can pick an application. Once picked, you will be sent to that application's page, where you can then find its viability against quantum computers. With the research that we have already done during phase 1 of the project, it would be feasible to create the website as we have envisioned. We believe that the impact of this tool will do well to close the gap between application security now and application security with regards to quantum computers. Throughout phase 1 of this project, we collected information about different applications that are commonly used throughout the workplace. We then collected data on each application to find out how they hold up against quantum computers. For phase 2, we'll start by creating the layout of the website. This will be first done through hand-drawn sketches of how we would like each page to look. Then transition these sketches into interactive layouts using software like Adobe XD or the layout functions within Wix.com. Once we are happy with the layouts created, we will then move on to creating a template for each web page. This includes adding functionality into the templates. The third stage of the project will be adding in all of the data collected during phase 1. Finally, the fourth stage will be dedicated to testing. This testing will be done before and after we release the website, making sure that it is functioning the way we have intended it to be. We have created a few milestones that we wish to achieve throughout the duration of phase 2 of this project. Creating the templates will be the first, as this is when the website that we have envisioned will start to take shape. The next milestone is adding in all the data collected during phase 1 into the web pages, as this will be when we first see all the web pages with all their data added in. The third milestone would be after the second round of testing when the website is live. This would be the first time Nathan and I have ever created and released our own website. So we would be accomplishing something that neither of us has done before. The final milestone would be presenting the final product to our peers, is to get feedback into any improvements that we would make going forwards with the website.